Guys, Mr. Bowman here. Today's learning objective is in red and we are learning to calculate the expected number for given scenarios. The first thing I want to emphasize before we chat about expected number, there is another similar phrase that we use in probability called expected value, which we're going to learn about in the next video. I do want to know that's slightly different to the skill we're learning here to do with expected number. So let's try not to get those two ideas confused. The very first thing I want to look at for expected number is the formula that you need to be familiar with. So we got E brackets X is equal to N times P. And let's break this down into its three components so you know exactly what they mean. So this E here, this stands for the expected number, the expected occurrence of event X. Whatever event X is. N's a weird one. N relates to the number of trials. And the number of trials is a weird way of saying it's the number of times the event X could occur. So if you were throwing a coin, each coin flick would be a trial. If you threw 10 coins, each 10 coins separately is a trial each. There'll be 10 separate trials. And down the very end, P, I'm sure you'll be shocked to hear that P relates to the probability of event X occurring. So probability of event X occurring. And you may be given the probability, but you may have to use a probability tool like we learned in some of the other videos in this topic to actually go ahead and calculate that. So let's jump to question number one. And actually, while we're here, if you know this guy, let me know who you think he is. But question number one, if we have 60 coins which are thrown into the air, how many would you expect to land on tails? And keyword is, I'm seeing that word expect come up, so that's my cue, my hint to think about expected number. So the first thing I need to figure out is my probability of the event. In our case, we're trying to find the probability of tails. This one here is nice and easy. That's going to be 1/2 or 0.5. Now that I've got the probability, I'm going to move on to the expected value side of things. So the expected number of tails. So notice I'm getting rid of the X and I'm putting in tails because that's what I'm interested in. That's going to be equal to N times P. The N value, the number of chances of a tail, that relates to the 60 coins. So there are 60 trials because there's 60 different coins that could have landed on tails. So it's going to be 60 times the probability of getting a tails. So that there is going to be, I've written a 0 first, but that's going to be 30. For these questions here, I do encourage you to finish off your answer with a bit of a sentence. So what I'm going to say is, we are expecting 30 of the coins to land on tails. And do forgive my messy handwriting there. So that's question number one. Let's have a look at question number two. This time around, we've got 600 die. So that's nice. Each dice would represent a trial. So that's our N value there. If we drop it from the sky tower, I'm not sure why we would do that, but there we go. How many would you expect? That's my cue to use expected number to land on 1 or 2. So probability of 1 or 2, that's going to be nice and easy. That's going to be 2 out of 6, which is 1/3. Our expected value, so the expected value of getting a 1 or a 2, that's going to be equal to N times P. We already know N, which was 600, the different dice being thrown off the sky tower. 600 times 1/3, which was the probability. We figured that out before. Timesing by 1/3, same as dividing by 1/3, so that's going to be equal to 200. So we expect 200 of those die thrown off the sky tower to land on a 1 or a 2. Just a reminder to put that in a sentence form somewhere. I'm not going to do it for this question, but hopefully you do that when you're answering your questions. And the very final question, number 3, a bit more of an annoying one. If you draw a card and put it back from a standard pack of cards 200 times, so there you go, that's our N, how many times would you expect to get a face card? So our first step here, let's find the probability of a face card. And a face card, hopefully you remember, that relates to jacks, queens, and kings. And there's 4 of each, so that's going to be 3 times 4, which is equal to 12. So that means 12 of the 52 cards in a pack of cards will be these face cards. And if we simplify that a little bit more, that's going to be 6 over 26, which is going to be 3 over 13. So I've got my probability now. I'll probably leave it in a decimal form this time. Let's think of expected values. So we've now got the expected value. Oh, I've written X, but we can be a bit more detailed that. The expected number of face cards is going to be equal to N times P, which is going to be equal to 200 times 3 over 13, which is going to be equal to 600 divided by 13. At this point here, I'd encourage you to grab your calculator out to see what you get. Hopefully you're getting a messy decimal number. I'm getting 46.15. And that there was subjected to a 2DP rounding. Now, that it's a decimal answer actually makes it very interesting because you're never, ever, ever going to have 0.15 of a card being a face card. So our sentence needs to be a little bit different here. So I'll just show you how I would write my sentence. So we are expecting, and I'm going to go 46 or 47. This being the number rounded down, and this being the number rounded up. So 46 or 47 face cards when drawing from the pack. And this part here, that will be really important if it's a messy excellence question. Without that contextual understanding of not being able to get 0.15 of a card, that's really important. You won't be getting excellence without that type of statement. So that wraps up our expected number video. Thanks so much for watching. Work hard on your probability, and let's keep an eye on the next videos that are going to be coming out shortly.